Okay, pendulums. So pendulums were a string attached to a weight, hangs down. That's what we would call equilibrium. Then you would pull it back to some position. This is excellent. You would pull it back to some position there. And then what would happen is you would let it go. And when you would let it go, it would swing from one side over to the other and then swing back again. So that's what a pendulum is. Springs, similar to that. So you have some sort of spring attached to something. It's got weight hanging on it. And then what happens is you stretch it out. Okay. This, by the way, is some distance we'll call D. This is stretched out also some distance. We call this X so we don't get them confused. And then what happens is the spring bounces up and then bounces back down again. And just like the pendulum continues that pattern. Okay, so that's what springs are. Pendulums are. Let's see what we remember. Woo! I am very, very excited for this. Tell you that much. Okay. You just got to be better. Just got to be better in period 1. Okay. I'm sure you'll be better in period 2. Period 2 didn't get any of these right. It's a different class, but don't worry about that. All right, ladies over here on the side, pick one of these things and tell me something about it. Doesn't have to be complicated. It could be something simple. Tell me something about one of these. Okay, so it was the thing we measured. Yeah, so we measured for both of these. It was basically the time to make one oscillation. So the period for a pendulum is this, going back and forth. Oh, there we go. Going back and forth. And the period, same definition for a spring, is this, the up and down motion. Okay, so period for a pendulum would be the side to side. Period for a spring would be the up and down. It's the time it takes to go once. Time it takes to go once. Okay? There we go. Look at that. We got one right already. This is excellent. All right, Cuisine, what you got? Give me another one. Pick any of them. I don't care.
Okay, so the period is directly proportional to length.
To length?
Yeah.
Yes. So length, if you increase the length, you will increase the period. It will take longer. So length for a pendulum is, you mentioned directly proportional. That is exactly the way I would phrase it. So period is directly proportional to length. So if you increase the length, you increase the period. It takes longer. If you increase, or if you decrease the length, you decrease the period. It takes less time. Okay. Excellent. Excellent, excellent, excellent. Okay. All right. Mason and Brandon, what's something y'all got?
Mass.
Yeah, what you got?
So, for a spring, mass has an effect on it.
Yep.
But pendulum doesn't.
Correct. So pendulum has no effect for mass. Okay. Spring mass does have an effect. It is inversely it's directly proportional. So if you increase the mass, you would increase the period as well. So period is directly proportional to mass. Excellent. Okay. Look at us being halfway done. All right. All right. Parker and Matthew, give me something else. Matthew, you got anything? No. No. Let's talk about spring constant. You remember what spring constant is? Parker, you remember what spring constant is? I'll give you a hint. It has to do with springs. That's not a bad way to phrase it. I'm going to change your phrasing just slightly, but it's a measure of like the strength of the spring. So like how bouncy it is not a terrible way to describe it, but I would describe it as the strength of the spring. It's worth mentioning this one is inversely proportional. Oh gosh, that is just not even remotely how you spell it. Spell it the right way, don't spell it my way. Inversely proportional to period. So it's how strong the spring is, and it's inversely proportional. That means if you increase the spring constant, you decrease the period. So the stronger the spring, the less time it takes. All right, we're getting there. We're getting there. We're getting there. Y'all up front, what you got for me? Got anything? No. Let's look at restoring force. What makes the pendulum move? What is the thing? Say again? So that's what starts it, yeah? What gets it to move? Seth liked what other people were saying. Gravity is the answer, yes. It's actually a combination of gravity and the tension in the string. You don't have tension in the string without gravity, but if you only have gravity, it's free fall, so you need the string as well. So the restoring force is a combination of tension in the string and gravity. It's probably worth remembering what restoring force is. Restoring force is the force to get back to equilibrium. And it's probably worth reviewing what equilibrium is. Equilibrium is the beginning, like the neutral point. It's the point where everything is in balance. So think about where is it when nothing else is going on. Okay. We only got 3 left. We're almost there. Almost there. Jay and Zach, what you got for me? Restoring force. What's the force that works on us? Like, why does the spring move? What's acting on the spring? There is gravity. Gravity, however, is going to be generally consistent, and so it's not going to have an overall effect, but that's a good guess. Applied force from what? From the... Huh? So tension in the spring? Yeah. I'm going to put those two together. So it's an applied force by the spring itself. Technically, it's the tension in the spring. But that's a good way to talk about it. So the restoring force is caused by the strength of the spring itself. Okay, and the way we've been avoiding amplitude like the plague. Anyone got amplitude? What you got for me?
No effect for pendulum.
Yes, so there is no effect on pendulums. just to recap what amplitude is. Amplitude is how far you pull it back. Half. There we go. How far. So amplitude where's the orange when you need it? Amplitude is this, how far you pulled it back. Okay, over here. It's this, how much it stretches out. Well, there we go. Okay. Okay. Amplitude has no effect on pendulums. Springs? Anyone remember? Effect on springs? Directly proportional. Good guess. Anyone else? Huh? Also no effect? Anyone going to go with inversely proportional? Let's just get all three answers up there. There we go. Yeah, we got a couple of people on inversely proportional. I love it. All right. The answer to this one is no effect. There is no effect on springs. Excellent. I love everybody. I love equal representation of the answers, though. Gotta have that. Gotta have it. It's America in 2024. We gotta have equal representation for everything. Okay. All right. Excellent. Totally got all those right on the first try. Perfect. Okay. Go ahead and jump to the back. Let's take out these last couple, and then we'll see where we are. We may get to the problem. We may wait and do the problem later. These ones, I'm not going to make you do most of these. All right. What are the two things that affected the period of a pendulum? We just talked about one of them, and that was length. The other one we mentioned in the restoring force part, and that is gravity. It's also worth talking about springs. I didn't have springs listed because I ran out of room. For springs, we also talked about those, and that was mass and spring constant. Mass and spring constant. Okay. All right. Why did amplitude not affect the period of a pendulum? Any ideas? Why did they not affect here? We're almost done here. If you want to fill it up, you can use the sink in the back. That's what I use. Okay. I'll get you here in a second. We're almost finished with this. Yeah.
Because if you pull it back further, it goes faster.
Yes, and that's because it has more energy. Yep, you're exactly right. It goes faster. Why do you suppose the amplitude does not have an effect? Because pulling it back more makes it go faster. Yep. And you could say that's because of more energy. Or you could say it's more restoring force. Totally fine with either of those. Perfect. All right. Why do you suppose that mass does not affect the period of a pendulum? So why do you think mass does not matter? So we said mass had no effect on a pendulum. Yes, we said mass had no effect on a pendulum. So if mass has no effect on a pendulum, why? Any ideas? Why do you think mass does not matter?
Because it's more mass that's affected by gravity.
Yes. So more force from gravity. Yes. So if you increase the mass, you increase gravity's effect on it. So increases the force of gravity as well. So if you increase the mass, you increase the force on it also. So similar thing, you're increasing the restoring force. So mass is harder to move, but it's also got more force to move. Okay. Two pendulums, identical, except I'm pulling pendulum A back twice as far. Okay? Which pendulum has the larger period? How do you know? Which one has the larger top speed? How do you know? Which one has the larger restoring force? How do you know? Just start with what you think the answers are first. We'll talk about the how you know in a second. But talk about those and see what you guys have. Parker, if you want to go over your hand. If you want to go now. So which one has more? Your answer choices are A, B, or the same. It could be the same, so equal. A, B, or equal. So A is going to have more speed because it has further to go in the same time. By the way, the reason why amplitude does not matter, we said that here on the front. We said it's because it depends, like amplitude is how far you pull it back. The reason that doesn't matter is because when you pull it back further, you give it more energy to make up for the fact that it has further to go. So it has more energy to make up for the distance. Hold on, y'all. Well, don't worry. We'll get done in time. I promise. Okay. And then which one's going to have the largest force? Posey?
I think they're the same.
Okay. Why?
Because like pendulum.
Because what?
Like the same.
Okay. Okay. Hey, no, Posey, you're the only one who's bringing your A game. Man, maybe it's your B game. That's okay. Hey, you brought a game. You brought a game to class, Posey, and I love it. Love it. Love where Posey's head's at. That's not right. That's okay. That's okay. Nothing wrong with that, Posey. Nothing wrong with being wrong. It's not a test today. It's not a test. Okay? Takers, it's not B. It's A.
Oh, I know why.
Why?
Because the more pullback you have, A has more pullback in the middle because it travels a further distance to get there.
Yeah. So it's got to have more force on it to do that. So restoring force. So restoring force increases as you get further from equilibrium.